All right, example number 2. A rectangular storage container with an open top needs to have a volume of 20 cubic feet. The length of its base is twice as long as its width. Material for the base costs $20 per square meter, and material for the sides costs $12 per square meter. Find the cost of the material for the cheapest container. Okay, I like to start by just kind of sketching a picture of this real quick. So I have some box here. Right? Maybe I should have done dotted lines here. And I have this base area that's going to be more expensive than the sides, right? It's got to be a little bit thicker. Maybe it's got to support some weight or something. So could I come up with a function for this cost? They tell me, so I have a height. They also tell me my length is 2 times whatever my width is. So I could kind of fill that in, that my length is the same thing as 2 times my width. And here's my width, there's my height. So the first thing I would do is I would say, you know what, I need a function for cost, because that's what they're asking about. So what would a function for cost look like? Well, it's $20 times the base area plus $12 times, and we could call this the lateral area. All the areas are on the side. You can call that the lateral area. So you have the base area plus 12 times the lateral area. So we have the cost, but we need something better than this. Well, we know what the base area is, actually. It's just length times width. But we also know the length is 2w. It's 2 times whatever the width is. So we could just say 2w times w. So we actually know what the base area is. It's going to be $20 times our base area is actually just 2w squared plus 12 times our lateral area. And what is our lateral area? Well, if you think about it, we have 2 congruent sides. We have these sides. And maybe it's about to get really messy here, but we also have the front, you could say, and the back, okay? So let's do the front and back first. The area of the front here, they're going to be the same, is going to be h times the length, or h times 2w. But remember, there's 2 of them, so I'm going to have 2 times h times 2w, so that is 4hw. Plus, now we could do the sides, and that's w times h. Again, I have 2 of them, so plus 2hw. And I could simplify this a little bit now. So I have a cost function. It's 20 times 2 is 40 w squared. And 4hw plus 2hw, I could combine that to 6. And 6 times 12 is 72. So I have 72 hw. Now this would work okay, except for this little pesky h here. I don't know what h is, and so I don't want a function with 2 variables. It's going to get a little crazy. So what I can do is I can actually solve for h, because they gave me another piece of information in here. They said the volume is 20 cubic feet. So let's play around with this. I'm going to play with it up here. If the volume is 20, well, what else is the volume? Isn't the volume also length times width times height? That's also the volume. And we actually know that the length is 2w, so it's 2w times h equals, we'll just say 20 for now. So I have 20 equals 2w squared times h. Well, maybe I can solve for h in terms of w. So let's just go ahead and divide both sides. And this looks, so these guys would cancel. I just have an h equals 20 over 2w, and that reduces, right? We can make this 10 over w squared. So let's clean this up a little bit. That would mean that h is the same thing as 10 over w squared. Well, that's very convenient, because that I can plug in for my h here. So let's go ahead and do that. H equals 10 over w squared, so I can rewrite my function one more time. Cost is 40 w squared plus 72, and instead of h, I could put 10 over w squared times w. now, I'm just checking my work there. Now, I could clean this up a little bit. This would be 720, and one of the W's from down here would cancel with this W up here, so it's just 720 over W. All right, I have a cost function. Now, let's go back to what we were originally trying to do. We just did a lot of math, got a lot of information down. Let's try and figure out what our goal is again. It's find the cost of the material for the cheapest container. So I want the minimum of this function. Well, that's no big deal. I know how to find maxes and mins of functions simply by taking the derivative. So let's go ahead and start deriving. I'm going to zoom way in so I have plenty of space to work. So we could say that C prime is equal to 80W plus, remember this is just kind of like 720 times W minus 1, so this would be negative 720 to W to the negative 2 power. Okay, and remember we're going to also take the second derivative to test it. That's one of the things that we did when we're testing for the min or max. So let's go ahead and take the second derivative as well while we're here. So the second derivative would go ahead, that would be 80 plus negative 2 times 720, that's 1440. And that's W to the negative 3. All right, so now I have a derivative and a second derivative. Well, to find my critical numbers, I'm going to go ahead and set the first derivative equal to 0. And so let's write this out. I would have 80W minus 720 over W squared equals 0. And I'm just solving this to find my critical numbers. Okay, well, I can just move the negative 720 over W squared to the other side. So I would get 80W equals 720 over W squared. This is like 80W over 1. I could cross multiply. I get 80 W cubed equals 720. I could divide both sides by 80, and I would get W cubed equals 9. And lastly, to take the cube root of both sides, and I'm just going to write it over here, we would get W equals the cube root of 9, which is about 2 point something. So we found the critical number. Remember that we want to test that in our second derivative to see if that's positive or negative, and if you plug that in, well, what is the cube root of, or the cube root of 9 to the third power is just going to be 9. So this is like saying 1,440 divided by 9. Well, nowhere are we going to get negative numbers here. So this is definitely going to be a minimum because it's when the thing is concaved up. So this must be a minimum. So that's good news. We found the minimum. That's what we were looking for. So what do we need to do? Now they just say find the cost of the material for the cheapest container. Okay, well, we have our cost function here. Actually, I simplified down here. I'm just going to plug that in. At this point, you're probably just going to go for a calculator because it's going to be the cube root of 9 squared times 40 plus 720 divided by the cube root of 9. And so yeah, this is really just plugging into a calculator. So you could say C of the cube root of 9, which we know is our minimum, is going to be $519.21. So there, that was fun. All right. For practice number 1, I want you guys to just try it on your own first. I will say this. This is where a lot of people get hung up. Notice that your factory is making 100 shirts at a time, and so the function that they give you is per 100 shirts, okay? So X isn't a shirt, X is 100 shirts, so keep that in mind, okay? Give it a try. I'm going to work it out and post my work and I'll box some of the key parts, but I really want you guys to just try this one on your own, so give it a shot and then maybe just unpause the video in a few seconds. Okay, so a couple things I did here real quick. First of all, I said the income has got to be 800 times X. That means for one batch of 100 shirts, 1 times 800 should give me $800. That's how I came up with that function. And 2 batches of 100 shirts should give me $1,600. So 2 times 800 is 1,600. So that's how I came up with that. So income minus cost, which I came up with this expression, or I used the formula they gave me. Simplified that down, and I got my equation for my profit. I then took the first and second derivative of that function. I took the first derivative, set it equal to 0 to find my critical numbers. I had to use the quadratic formula, and I got two values, negative 14.29 and 18.299. Obviously, I'm not interested in selling a negative amount of shirts, so I just crossed it off right away. And then I used this 18.299 and checked it in my second derivative really quick. When I plug in a positive 18.99, I get a big negative number, which means that I'm concave down at this point, so this value is definitely a max. Here's the problem with that value, though. They said here my factory makes 100 t-shirts at a time. I can't make 1,829 shirts or 1,830 shirts. I can only make even hundreds. So that means my max has got to be either 1,800 shirts or 1,900 shirts. So I've tried both of these in my profit function, 18 and 19. And I see that I make a little bit more at 1,800 shirts. So 1,800 shirts yields a max profit of $10,242. Hope you enjoyed it. See you guys in the next video.